So up to this point, we've been using just geometry to model everything, right? We have been using triangles for implementing the various faces and polygons, and we've been looking also at using lots and lots of triangles, to be able to model fairly complex shapes, right? And but certainly, today's hardware can definitely deal with tons and tons of these triangles. Millions and millions of these polygons per second can be rendered with some of the modern graphics card. But even with this power of processing, it's not sufficient to deal with some of the more complex phenomenon. If you're doing smoke, if you're doing clouds or any gaseous material, or things that contain lots of millions and millions of blades of grass and leaves, or also the intricacies of terrain on a planet, or some in the woods or things like that, and or skin and hair. So certainly some of these are much more complex and challenging, and even with being able to render millions of polygons, you'll be looking at trillions, bazillions, Google zillions of triangles to be able to handle and accurately simulate these kinds of phenomena. So certainly we need to consider other alternatives to to simulate these phenomena. And so what we're going to be looking at, it says, well, what if I took a snapshot or picture of some of these things and used it to wrap a less complex geometry that might have indeed a couple of 100,000 surfaces and triangles, but if I wrap it around with a picture of some fairly complex representation or image of clouds, of smoke, of grass, and I understood how light and the environment interact with one another as you're looking at it from different points of view, right? And I could randomly generate, for every pixel on the screen, I could calculate on the fly, what are the normals that would be relevant in that particular surface. Then perhaps I have a fighting chance at rendering something that looks somewhat believable. Obviously, if I know that I need to render just a specific pixel on the screen, it would make no sense that if that pixel, I need dozens, hundreds, thousands of triangles that all represent that one pixel. I would be wasting processing power at dealing with those that many triangles if I'm only going to just render a single pixel on the screen. So more interesting would be how can I go backwards, right, from a pixel on the screen back into the model, back into an image, right, that would tell me how that might render, and that would be much more efficient. So that's where our focus is going to be in this set of presentations, and how can we efficiently be able to render things that are extremely complex, right? But without the burden of having to render, the geometry and the model be behind it.